Welcome back, grade 10s. I want to continue with examples working with gases and their volumes. So this is remote lesson 9, and we'll carry on with these examples. So to work through these examples, we will need balanced equations. From Avogadro's law, we know that if the volume and pressure at the same temperature of any gas would have the same number of particles, so we get the volume ratios between gases equal to the mole ratios. So hydrogen reacts with chlorine to form hydrogen chloride. Write down a balanced equation for this reaction. Write down the mole ratio for the reagents, and then we'll calculate the number of moles if 11.2 cubic decimeters hydrogen chloride is formed at STP. And then we'll calculate the volumes of the hydrogen and the chlorine that reacted during this reaction. So first of all, to write a balanced equation, we say hydrogen, which is a diatomic gas, plus chlorine, also a diatomic gas, it will form 2 moles of hydrogen chloride, a gas. So for B, we write down the mole ratio. So 1 mole hydrogen will react with 1 mole chlorine to produce 2 moles of hydrogen chloride. Number C, calculate the number of moles if 11.2 cubic decimeters of hydrogen chloride is formed. So the given volume is 11.2 cubic decimeters, and they want us to calculate the number of moles. Number of moles is volume over molar volume, which is 11.2 over 22.4, which gives us 0.5 moles of hydrogen chloride. D asks us to calculate the volumes of hydrogen and fluorine that reacted during this reaction. I'm going to take the short way, or maybe I should take the long way. Let's take the long way first. This is the moles of hydrogen chloride formed. The moles of chlorine formed will be half of the moles of hydrogen chloride, because the mole ratio chlorine to hydrogen chloride is 1 to 2. So 0.25 moles of chlorine will be used in this reaction. And the mole ratio between chlorine and hydrogen is 1 to 1. So if 0.25 moles of chlorine was used, 0.25 moles of hydrogen would be used. So the volume of the hydrogen would be the moles times molar volume, which is 0.25 times 22.4. And we get the answer. A quarter of that is 5.6. And the same calculation will result in the same volume. The volume of chlorine will be 5.6 cubic decimeter. I didn't have to calculate these values because of Avogadro's law. If I've got 11.2 cubic decimeters of hydrogen chloride with a mole ratio 2 to 1, the volume of the chlorine will be half of that, which would be 5.6 cubic decimeters. And the volume of hydrogen would be exactly the same because the mole ratio is 1:1 for hydrogen to chlorine. So it's 5.6 cubic decimeters. Right, I'm moving on to the next example. If the volume calculations are not at STP, then we can't use 22.4. Then we have to use the molar ratio. So let's use the mole ratio. What volume of oxygen is needed for the complete combustion of 2 cubic decimeters propane? C3H8 is the formula. Now, you don't have to worry about this. In a test, we will guide you. But combustion means, and this you need to worry about, reaction with oxygen. So C3H8 will react with oxygen. Both these reagents are gases. They will form carbon dioxide, which is a gas, and water vapor, which is a gas. We need to balance this equation because we need the mole ratios. Now to balance this, I've got 8 hydrogens on this side and only 2 on that side. So I'm going to give it a shot. 4 waters will be produced. I've got 3 carbons on the reactant side and only 1. So I'm going to say 3 carbon dioxides will be formed. Now we need to check out the oxygens. 3 times 2 is 6, plus 4 times 1, that makes 10. To make 10 oxygen molecules, I need to multiply the oxygen molecule by 5. Sorry, it's 10 oxygen atoms. Molecule multiplied by 5. So our mole ratio is 1 mole of propane will require 5 moles of oxygen, 3 moles of carbon dioxide, and 4 moles of water vapor. I'm not allowed to use 22.4 to calculate anything here, but they say 2 cubic decimeters of propane is combusted. So 2 cubic decimeters of propane will require 5 times that amount of oxygen because the ratio between the propane and the oxygen is 1:5. I'm using that ratio to determine the volume. So it's times 2 by 5. So you'll require, this reaction will require 10 cubic decimeters of oxygen. From propane to carbon dioxide, 1 mole of propane gives us 3 moles of oxygen. So times 3 to get the volume of the carbon dioxide formed. That will give us 6 cubic decimeters. And lastly, the water vapor that will be forming is 4 times that of the propane. So it will be 8 cubic decimeters. So we use mole ratios to determine the volumes of gases if we can't work with STP and 22.4. Right, I'm ready to move on to the next example. The next example asks us to calculate the volume of oxygen needed to convert 300 cubic decimeters of sulfur dioxide into sulfur trioxide. So we've got sulfur dioxide gas reacting with oxygen gas, and it forms sulfur trioxide gas. We need to balance the equation. Two sulfur trioxides would be formed by two sulfur dioxides reacting with one oxygen. So the mole ratio is 2 moles to 1 mole to 2 moles. And they want us to calculate the volume of oxygen if we start off with 300 cubic decimeters of sulfur dioxide. Now the mole ratio, if you can see the mole ratio here, the mole ratio is 2 moles of sulfur dioxide will need 1 mole of oxygen. So I need to get the volume by dividing the sulfur dioxide's volume by 2. So the volume of the oxygen required would be 150 cubic decimeters. One last equation here, or calculation here in this video. Volume ratios are the same as mole ratios. Right, what volume of ammonia gas is produced when 700 cubic centimeters of nitrogen gas reacts with enough hydrogen gas is the question. We need a balanced equation. It's nitrogen gas reacting with hydrogen gas to form ammonia gas. Called a homogeneous or homogeneous reaction when everything is in the same state. We need to balance this reaction. I multiply the ammonia by 2 and the hydrogen by 3. Then it would be a balanced equation. 1 mole of nitrogen will need 3 moles of hydrogen to give 2 moles of ammonia. What volume of ammonia gas will be produced if we start off with 700 cubic centimeters of nitrogen? The mole ratio is 1 mole nitrogen will give 2 moles ammonia. So I use that and I multiply the 700 cubic centimeters by 2, and we get 1,400 cubic centimeters, which is equivalent to 1.4 cubic decimeters. Right, this brings us to the end of this video. See you in the next class.